So hello guys and welcome back to my YouTube channel. In this video today we shall be talking about LangGraph memory. So we've been building our chatbot without adding memory, and then the AI cannot remember our conversation. So in this tutorial we're going to be adding a memory to enable the AI to remember our conversation and respond like it is a continuous conversation. All right, so LangGraph supports two memories. It supports the short-term memory and the long-term memory. So I'm going to explain the short-term and long-term memory. All right, so if you are used to your ChatGPT, you notice that you will create different threads for different conversation. All right, so and each thread, it remembers what you have been talking about in that particular thread. Do you understand? So if you want to start a new conversation, you can open another thread. All right, so that is what is regarded as short-term memory. Short-term memory is the in-thread memory, where the AI remembers your conversation in between a particular thread. Do you understand? So each of them are being identified by what is called a thread ID. All right, then the long-term memory is when the chatbot can have knowledge of your entire conversation as a user. Just for instance, in your ChatGPT, there are a few things that you might talk about that ChatGPT might store. That when you are now communicating in another thread, it will be able to remember those few details, maybe what you're working out at a particular time or things that you have done. That is called long-term memory. Remember, it is different from short-term memory. Short-term memory is just remembering the entire conversation in one thread. All right. So in LangGraph, the short-term memory is being handled by the LangGraph checkpointer, while the long-term memory is handled by the LangGraph store. All right. So let's move forward. So what have we been doing? So this is what we have been doing so far. All right. So building a simple chatbot. So let's run our code. So these are our different imports. I run this, then initialize the LLM. So now what we are actually doing here is just basic thing that we'll do. This is the node, okay, which we are using the messages state. Pick the list of messages, pass it to the LLM. All right, get the response, update the state, and then this is our graph. Add the LLM call as a node, then add the edge from start to LLM call, from LLM call to end, then we compile. So this is what we have been doing for now. All right, so this is our graph. So let's query the graph. So we can say, who are you? Just very basic. Okay, so it gives us a response. All right, now if I ask another question, what can you do for me? All right, so it gave us a response, but then you will see that the only messages we have in the response, like you can see here, let me print results. The only messages we have here are just two messages. All right, which is the immediate question we'll ask now. It doesn't remember our previous conversation, no detail about the previous conversation or the previous questions we have asked. So whatever happens is, once you invoke the graph, it starts afresh by updating it with what it has, like the fresh input that you made. So if I say now, let me say my name is Felix. All right, so Felix, what can I do for you today? So I'll ask it now. Do you remember my name? All right, then it didn't remember my name. Do you understand? So this is just basically what we have been doing now, and this is a limitation. Now let's add memory to our agent or to our graph. All right, so we are importing MemorySaver from graph checkpointer.memory. Now, this memory saver will enable us to save our conversation in the memory of the system, that is on the RAM. All right, so we don't have a persistent storage, but we're going to use this to understand how the checkpointer work, how the short-term memory work. All right, so you can build a persistent memory with your databases. You can build with SQLite, you can build with MongoDB, you can build with Postgre. I shall be making individual videos about this and how you can set them up. But for now, to understand how it works, we are going with the memory saver. All right, so we run this to import this library here. All right, then this is just what is different from what we are doing here. We create the instance of this memory saver, call it memory, and when we are compiling the graph, we pass checkpointer is equals to memory, and then this will have a memory. All right, so let's run this. Just as simple as that. Then for us to invoke our graph, remember it needs an ID to remember each conversion. So we are going to be passing a thread ID. All right, so this is our thread ID here. And to pass the thread ID, we'll pass it as a configuration data. All right, so this is the syntax to pass configuration data to your graph. There are some other data that you can pass it if you are using the long-term memory, which is the user ID and the rest, but we are on the short-term memory here, which is the checkpointer. Okay, so configurable is a dictionary. The configurable key is holding the thread ID. All right, thread ID is thread ID. So while invoking your graph, you're going to pass config is equals to your config here. All right, so, and remember our point of interest, thread ID. Okay, so now let me run this now by saying who are you? All right, then it gave us a response. Now let me ask another question now. What is my name? All right. Okay, sorry, I have not passed my name yet, but then you should understand that now. You see we have two conversations now. The first one, this is the response. The second one, this is the response. Then let me pass my name. Let me say my name is Felix. Then it's already knows my name. Nice to meet you, Felix. And you see that all our conversations are here. Let me print the results so that you understand what I'm saying. You see that we have how many messages here now? 1, 2, 3, 4, 5, 6. We'll have 6 messages. All right, so now let me ask it a question. Do you remember my name? All right, let's look at the response. Yes, I remember your name. It is Felix. Because the list of messages we are passing to the LLM, it reads this conversation and it knows that, okay, your name was here at some point, and it remembers the name. All right, so, and if I run this, I'm going to be getting these messages now. All right, so let me show us one more thing. Let me pick this and let me use a different ID. This is 1, 2, 3, 4. So let me use 5, 6, 7, 8 as an ID, and I am asking, do you remember my name? Okay, so let's run this. You see, it doesn't have a record of my name here because this is a different thread. Do you understand? This is a different thread. So, and in this thread, it stores this other conversation differently from this other conversation now. So in the memory, it stores those different conversations there. All right, so this one with a fresh thread is there, and then this one with a different thread is there. All right, so if I now run this again with this thread ID, and I ask another question, let me ask a question like, what can you do for me? All right, so if I scroll down, now you see that I have all those other conversations here with me till this last one. What can you do for me? Because this is a different thread. And if you add another thread, it is going to start a different thread of conversation. Just as you can see here, the message is still increasing. All right, so with this now, we'll be able to add memory to the LangGraph. But there is a problem. We have a limitation here. All right, so um, when you look at this now, you see that the number of messages is increasing, and as it is increasing, the token usage will be increasing. So the token it will need for the completion of each one will definitely be increasing. What do I mean? I'm going to show you something now. So if I pick, let me take result of messages. And I'm picking the last one, -1. All right, so, and let me say dot model dump, so that I can see it as a dictionary. All right, so this is the last message. All right, so I am looking at the token, I'm looking at the metadata. So this is where my interest is. My interest is at this token. Okay, so you see the total token this particular message took 1211 tokens. All right, now this is the last message. Let's look at the message before this one. So I'm going to pick this. I'm going to look at -2. Okay, this particular one is a human message. All right, so let's look at -3. So it's a human message. All right, so we are looking at this now. So you see the total token it took this. So as you are going, the number of tokens were increasing. As you keep making the query, the number of tokens kept on increasing. It kept on increasing. It kept on increasing. And if you don't manage this, that means for each conversation you make, for each chat, the number of tokens will be increasing, and it's very costly. All right, it's very costly for you using the LLM. That's what we call maximizing token usage. So what do you do in these cases? You need to delete some intermediate messages. So how do you handle this? Work with me. All right, so let's look at deleting messages. So remember for that, from your LangGraph messages will have this add message. You also have a function called delete messages. Okay, so how does this delete messages work? I'm going to show you. Remember that we'll have, when we have this list of messages, this is initial message, this is new message. If I call add, it's going to concatenate this to this. So let me call this now. Okay, I'm yet to run this. All right, then this should go now. Okay, so it concatenated this now to this when I ran this add messages. All right, so the same thing is being done when you run daily, when you run remove, when you run this add messages with remove messages. Remember, we are adding it with normal messages. We have the AI message and other. So, but when you are running it with an instance of remove messages, and you run this add message reducer, it is going to remove some messages from the chat. So how you do this is to create an instance of the remove messages and pass the ID of the message you want to delete. All right, so when you watch all these message instances here, there, all of them have an ID. Each of them have an ID. All right, so when you pick each message, when you pick the ID of each message and pass it to remove message, and it is in a list, okay, and then you run these add messages. Instead of concatenating them, the add message reducer will look for the messages that matches the ID you have in each remove message and remove those messages. Okay, so this ID belongs to okay, so I'm going to pick one of these IDs here. I'm going to pick one of these IDs here. So let me pick the ID of this particular message now. I'll pick the ID of this message and then I'll paste it here. All right, so I am picking the ID of this message. So this is the message we're interested in deleting. So I run this and then I pass it to the add message reducer. Remember, these are my messages. Okay, these messages now, that is what we have here. And we're passing it to the message reducer. So if we run this, you see that this human message was deleted. What can you do for me? Was deleted from this place. So when you are updating the graph state, and instead of passing a message, maybe an AI message, which is an instance of any message, you passed list, that is an instance of remove message. It is going to pick the IDs that is in each instance and remove that message from the list of messages. So this is how you can delete messages during conversation. This is how it works in LangGraph. So this is how it works. All right. Then remember what I said earlier. What you just need to do is to delete messages intermittently. All right. So, but if you delete these messages, you're going to lose context of conversation, because there are a few things that you must have talked about that the AI will not remember because the messages have already been deleted. So what do? You are going to create what we call a message summary. So those messages you want to delete, you're going to summarize them and then have the summary so that you can actually delete them. And then you can pass the summary to the AI and it knows, okay, these are summaries that are not here now. And then it can now understand the context and then continue the conversation. All right, so work with me. So to be adding this summary to our chatbot, we're going to create a new state. Okay, so we're going to create another state. So we're using this state now. All right, it's a custom state, but we're inheriting from messages state. And you remember, messages state has one key there, which is the messages, and then we add another key, summary. So we're inheriting from this. Okay, so we run this, and then this is the prompt to summarize our messages. Okay, remember we already have our prompt for the getting response, that is chat response from the AI, and then this is the prompt for to summarize. So your attacks with summarizing the conversation between the user and AI. Your summary should be precise and capture all the detail in the conversation, just as simple as this. Even though for production, I need to make it more extensive and tell it how I want the summary, which should be with context to what I'm building. All right, so I run this and then I'm trying to show us something here now. Now look at this function now. So if there are a number of messages that I want to delete, now I have, just like we'll have these messages now, they are 4. Okay, we'll have these messages, they are 4. So let me show us here. We'll have these messages, we'll have 4 messages here. So I can actually iterate here now and create a list with instance of remove messages with the ID of messages that I want to remove. How do I do that? You simply use a list comprehension. So first of all, I am iterating between the messages, and I am iterating from the first one to the last one. I am skipping this last one. All right, I am skipping this last one. That is why we have -1 here now. And for every message, I am creating an instance of remove message, and I am passing the ID which is a key, the remove message is equals to the ID of each of the message that I iterated on. So if I run this now, so you are going to see that I have a list of remove messages here. So this is how you create a list of messages that you want to remove while you are running your code, all right, while the graph state is running. This is how you create a list of the messages you want to remove. So that is why I have this here, so that you can actually understand it beforehand. All right, now let's look at what we are having here now. So I'm going to add more nodes. So I'm adding this node, which is the summarize messages. We're having another node. So you see that this node is actually different from what we are doing so far. So we're adding extra nodes. So let's look at this node, how they work. All right, so before we get to this LLM call, okay, so let's look at the LLM call first. Let's look at this before we look at this. So we are picking the states, all right, picking the messages, and then we are trying to get the summary from the state. So we say if the summary exists, get the summary. If not, return an empty string. That is, if the summary key has actually been populated, get the summary. Then if there is summary here now, so this is how you now constitute the system message. So we now say that the content is, you pass the system prompt. The system prompt will have it, we'll define the system prompt. So this is the system prompt. So these are system prompts, all right? So we'll have it above, and we are saying add it in these messages, then create some new line, and then we are now passing the summary, all right? So if there is summary, then create your system message this way and then pass the summary. But if there is no summary, just pass your system prompt to your system message. You don't need to pass the summary of the conversation, and then we'll just use it to invoke the graph. So passing the summary of the conversation in the system message enables the AI know that, okay, there has been some conversation and these are their summary. Do you understand? So if these are the summary of a conversation that has happened beforehand, it is going to reference it. It's going to reference it to generate the next response. So that is for the LLM call. Now let's look at the summary. Okay, so first of all, we are picking the messages from messages state. All right, then we are checking the length of messages. If the length of messages is more than 6, that means if we have up to 6 messages in the messages state, you might want to summarize. So in your own context, depending on what you are building, you can manage the number of messages you want to get to before you summarize by yourself. Do you understand? So, but here now, I'm looking at 6 messages. Then, if the messages is up to 6, get the summary if the summary exists. But if the summary does not exist, return an empty string. All right. So we now check if a summary was gotten, then the summary, we created a variable here, summary message, will pass this summary. But if there is no summary, we'll pass no summary of conversation yet. Okay. Then we now create our messages. Okay. So we create a format to store the messages. So now look at how the messages go. So taking into account the previous summary, you pass the summary. Summarize the following conversation, we pass the conversation. All right, so we now try to format this, and at the summary we are passing this summary message, and the conversation we are passing our messages. Then we now create a response. Remember, this response will just be a string to summarize this conversation. All right, so this messages is going as our human message, and then the system message we are passing our system prompt. When we now get this summary, we now create a list of the messages we want to delete. All right, so first of all, we are iterating between the messages up till the last 2. So I didn't want to delete the last 2, but I should delete other messages. Now creating instance of remove message and passing the ID as the ID of each message we iterated. All right, so with this is just what we did above here, which I showed us using list comprehension. All right, so once we have done this, our work is done. Then we are updating the summary with response.summary. Remember, we are going to be having just one summary, so we'll just be updating whatever that is there because we picked any summary we'll have there to generate the current summary. So we're updating it with the summary, which is this response.content. And then the messages, we are passing this delete message. So it's going to call the add message reducer with this list of remove messages with their ID and then remove the messages we want it to remove. All right, so but if you don't have up to 6 messages, it's going to return. So this is how the summary node works. It's very straightforward. All right, then we build our graph. So our graph goes from make the LLM call, summarize the conversation if necessary, and then no, this is just adding the node. So what we have here is first of all, it goes to summary, from summary to LLM call, and from LLM call to end. And remember, we are adding the memory saver. All right, so we're adding the checkpoint so that it can actually store our conversation, and then we can build the graph. So let me build the graph. All right, so this is the graph now. So the graph goes to summary, then from summary to LLM call. But remember, before this summary, when it gets here, all these other codes will execute if the length of messages in the messages is greater than 6. All right, so now let's start this conversation. Let me run this here. So I want to start from who are you? Just basic messages. Who are you? And then it got us a response. Now, I can be printing the results here to actually see what we have. So this is what we have, just 2 messages. Okay, so what can you do for me? Let's keep chatting. What can you do for me? We'll run this. It gave us a response. We see what we have here now is 4 messages. So let's continue now. Okay, let me just say my name is Felix. All right, and if we check now, we're having 6 messages. Okay, so now I'm going to ask another question now. So let me say, do you remember my name? Do you remember my name? So you will notice that the messages we have here has reduced. So now let's look at our results. So you notice that we now have a summary, because when I passed, remember, after the third conversation, we already have 6 messages. Now when I passed this other message, we now have 7 messages, and then the summarized conversation was able to execute, and then this summary has been populated here. So if I try to have a look at this summary now, so is result summary. All right, so okay, let me print this so that I can have a look at it properly. All right, now, so this is the summary of the conversation. So you see how it was able to situate how we are processing the conversation. So this is how it was able to. You see the long response it gave us before. You see how it actually kept it very brief. All right, so this is how it processes each response, and then we'll be able to say, okay, this is the summary. And then in the next question you are going to be asking, is going to take into consideration this summary to actually work. All right, so absolutely it remembers my name, even though it has done this summary because the name was here. So this is how you build a concise chatbot, adding memory and memory summary and messages summarization. All right, so this message summarization will enable you to deleting the messages. First of all, will enable you to reduce the number of messages that you are feeding to the AI. But for you not to lose the context of the chat at that particular time, you add message summarization. So this is just how a typical chatbot works, and you'll be able to get all the responses you need. If you enjoyed the video, give us a thumbs up, subscribe to this YouTube channel. There are tons of video coming your way on how you can build AI system, AI multi-agents. Just stay with us and you will receive a lot. Meanwhile, keep coding. See you in the next video.